This video is presented by Alia Natasha binti Zainal Abidin, Lailatul Zafira binti Zamahuri alias Zaman Huri, Nik Muhammad Faiz bin Dahlan, and Nurul Ain Syahira binti Abdul Basit.
Assalamualaikum. Today I, Nik Muhammad Faiz bin Dahlan, will talk about process description with PNID for packed bed reactor. A high packed bed reactor was used for operating hydrocracking reaction. The packed bed reactor was separated by three parts. It consists of three main systems: a feed system, a reactor system, and a product separation system. Feedstock, feed pump, and a gas cylinder including regulator were the feed system accessory. The derived pump oil was stored in the feedstock tank and fed by the feed pump and mixed with H2 before entering the second system. The reaction was composed of stainless steel tube with 100 ml working volume and catalyst was packed inside the tube. The hydrocracking occurred in the system. The operating temperature was controlled by two thermocouple inserts installed at the top of the bottom of the reactor. Temperature and pressure were strictly controlled to produce several conditions, while the feedstock flow rate was controlled by the feed pump and the flow meter controlled the gas. The derived pump oil and H2 were mixed and fed into the reactor at the bottom of the reactor. Finally, the hydroprocessed biofuel product was exported from the top of the reactor and continually flowed to condense at the heat exchanger to separate the liquid and gas in the third part of the product separation system. The liquid product could be harvested from a product tank and was further separated by distillation, and gas were released to the atmosphere. Three factors, namely temperature, pressure, and liquid holistic velocity, were investigated to determine their effect.
For description of packed bed bioreactor, the first point is in chemical industry, it is used in chemical reactions. These tubular reactors are filled with solid catalyst particles and are typically used to catalyze gas reaction. The chemical reaction occurs on the surface of the catalyst. The second point is due to cell immobilization within micropores matrices. Various cell lines can be cultured for long periods of time under low shear conditions. The third point is the flow of material through a packed bed is highly dependent on its performance, which is dependent on the packing and how flow is managed. Electrical tomography can be used to examine the distribution of liquids in the vessel various cross-sections. The last point for description is for the immobilization process. Various techniques such as covalent bonding, cross-linking, and absorption are commonly used. Because reactions in packed bed bioreactor are heterogeneous mass transfer, the system may play a significant role in determining reaction kinetics.
Next part is the schematic diagram of advanced reactor.
Component of packed bed reactor and its function. Typical reactors consist of a chamber such as a tube or channel that contains catalyst particles or pellets and a liquid that flows through the catalyst. The liquid interacts with the catalyst across the length of the tube, altering the chemical composition of the substance. For more detail, this type of reactor has thermocouples, electrical element, alumina jacket, grid, catalyst bed, asbestos, fire brick, furnace outer wall, and quartz beads. Thermocouples are sensors used to measure temperature. It is also to monitor catalyst performance and ensure that the temperature stay within an optimal range. For electrical element, it is a resistant coil which is designed to create heat by causing electrical friction. Alumina jacket, it is widely used in range of industrial applications to improve corrosion protection, wear and erosion resistance. Then grid, it is a removable screen and self-supporting filtration structure which used to retain the active media or catalyst while allow the gas or liquid to pass through. It can also withstand pressure drop over the catalyst bed during the entire catalyst cycle. Next, catalyst bed. It is to hold the catalyst pellets in place so it will not move with respect to a fixed reference frame as essentially all reaction occurs within the catalyst particles. Fire brick, it is built primarily to withstand high temperature but will also usually have a low thermal conductivity for greater energy efficiency. Then furnace outer wall, it is desired to keep the outer walls of furnace warm enough to prevent corrosion. And last is asbestos, it is used to protect machinery from high heat.
For advantages of packer bed bioreactor, the first point is the packer bed reactor has a higher conversion per weight of catalyst than other catalytic reactors. The amount of solid catalyst is converted rather than the volume of the reactor. The advantages of packer bed bioreactors over other bioreactors include enzyme reuse, continuous operation, low substrate and product inhibition, and high yield of desired product. These bioreactors are commonly used for food, beverage, and waste treatment. For the third point is the packer bed reactor process run continuously. And lastly, for this type of reactor has low operating and maintenance costs.